Let's take a look at some more span examples. So all the vectors that I have here is in R cubed. So the value of my m is gonna be 3. So one easy way that I can check whether or not these guys would span R cubed is that I can just form a matrix and see if the rank of the matrix is 3. Now for the first one though, notice that I only have 2 vectors here. So my n is equal to 2 and this is less than the value of m, which is 3. So I can actually conclude right away that this guy is not gonna be able to span R cubed. And that's kind of because if I have only 2 vectors, then there's no way these 2 guys can span something that has 3 dimensions. Now for part B though, if I were to form a matrix out of the vector here, I'm gonna have 1, 0, 0, 0, 1, 0, 2, 3, 0. Notice how this is already in the reduced row echelon form, but the rank of this guy is actually just 2. The rank of this guy is just 2. This is less than the value m that I want, so this guy is once again not gonna span R cubed. So even though I have 3 vectors now, but because the rank is only 2, so this is not enough. But if I look at the third one, well, if I were to form a matrix here, this is gonna just be the identity matrix. This is already in the reduced row echelon form, and the rank of this guy is just gonna be 3. And because the rank of this guy is equal to the value m that I want, I can then conclude that this guy is going to span R cubed. And that kind of makes sense because, well, this 3 guy is just the standard basis for R cubed. Now for part D though, we kind of already have done this in the earlier example 3.5. But if I were to follow this standard procedure, I can form a matrix out of these vectors and find the reduced row echelon form. We already done this in the example 1.6. So let me just go ahead and write the reduced row echelon form. That is going to be, let's see, 1, 0, 5, 0, and then 0, 1, negative 2, 0, and then 0, 0, 0, 1. I have 3 rows with leading 1 here, so the rank of this guy is going to be 3. And because the rank of this guy is the same as the value m that I need, so that means I can conclude that this guy is going to span R cubed. Now let's take a look at the last 2. We actually have already found the reduced row echelon form for the matrix that is formed by putting these 3 together in the example 1.7. So let me just write down what we got from there. For the first one, the reduced row echelon form is going to be 1, 0, 1, and then 0, 1, 3, and then all 0. So I have 2 leading 1. The rank of this guy is going to be 2, and this is not enough. So that means these 3 vectors altogether will not span R cubed. But for the last one, the reduced row echelon form for this guy is going to be just the identity matrix, and the rank of this one is going to be 3. So the rank of this matrix is 3. Let me actually do this in blue. The rank of this matrix is going to be 3. So I can conclude then that these 3 guys are actually going to span R cubed for sure. Yeah, so we see that we need at least 3 vectors to span R cubed, which has dimension 3. Sometimes having 3 vectors is enough, sometimes having 3 vectors is not. We'll see why this is so in the next lecture.